Hello everyone. In this lecture, we will extend our hacking progress and try to read system files through SQL injection. To do that, first we need to find a way to read system files in PostgreSQL. Because remember that in the previous lectures, we found out that the application is running with Postgres database. After some research, I found out that I can read the files using a PostgreSQL function. Basically, we need to use copy commands to move the data from a file to a table. In pgadmin query editor, here you see a function that I created for this purpose. It is called file_read. Let's go over this function together. I use a create function statement and pass the file name as text. I then specify that I will return a text from this function. So it will simply return the content of the file as a text in the response. I then declare two variables, one for file content and one for a temporary table name. Because I will need to use a temporary table in this function, as the copy command requires a table to be able to read the file content, and I will use a temporary table for this purpose. I then begin the function using begin statement, and then use quotes_literal function to handle escaping of single quotes, so that we can use the file name in the SQL statement safely. Expressions containing values that should be literal strings in the constructed command should be passed through quotes_literal function in PostgreSQL. Then I use file read temp table as the temporary table name and execute some DML queries, data manipulation language queries. First query will be a create temporary table with a text field called file content, and then the copy command to copy the content from file into the temporary table. I then select the content of the file using string aggregate function and put the content to the file content variable. Here string aggregate function gets a second parameter, which is the delimiter. And I supply char10 as the delimiter, which is line feet in Postgres. If I select char10, you will see it returns line feet character. Well, you cannot see it directly, but we see there is a new line here in the response. So I just wanted to use line feeds as delimiter to get the content of a file line by line. Finally, I drop the temporary table and then I return the file content from the function. As you see, I use PLPG SQL language to create this function, as it is stated at the end of the create function statement. Alright, let's create this function in PostgreSQL. As you see, the function is listed in the functions section of injection schema. Now if I run a select statement for this function, I can read the content of a file. So let's create a text file in the shared folder. So I will open a terminal and create a text file using VI editor. In the user's shared directory, I will name the file as test.txt and write some text inside this file with a line delimiter, that is with a new line. If I now return to the pgadmin and run select file read function by passing this test.txt file as the parameter, I will get the content of this text file, as you can see. Right, now we know that we can read files using a PostgreSQL function. But can we create this function and use it with our SQL injection exploitable application? Let's try that. I will first drop this function because normally there won't be such function available. We will need to create it using our exploitable application. So I will go to our application, start it inside IntelliJ, and then log into system. Remember that in the get user info link, we were able to use a query union select and get the data on the front end. So for a union select 1, 2, 3, 4, 5, I get this content 1, 2, 3, 4, and 5 in the HTML table in the front end. So whatever I select, I will get it on the response. In SQL language, you can finalize a query using semicolon. So for example, if I write select 1, 2, 3, then finish it with semicolon, and run another query with select ABC. And if I run this, it won't give an error, and will return the second select statement as the result, as you can see. So what happens if I close the query using a semicolon and send my create function query after it in our SQL injection attack? Let's try to do that in the next lecture.